If you flew a spaceship blindfolded through the asteroid belt, what are your chances of hitting a rock? Hollywood tells us it's a suicide mission. Han Solo said the odds of survival were 3,720 to 1. But the reality, if you fly blindfolded through the asteroid belt, you have a 99.999% chance of hitting absolutely nothing. The average distance between two asteroids is over 600,000 miles. That's 2.5 times the distance from the Earth to the Moon. If you stood on an asteroid and looked up, the closest rock would be too far away to even see with the naked eye. It's a ghost town. But here's where the mystery gets creepy. If the asteroid belt is so terrifyingly empty, why are astrophysicists obsessed with it? And why does this invisible wasteland hold the definitive secret to why you and I are currently breathing? This isn't a bunch of random space rocks. This is the grand blueprint of the early solar system, violently torn to pieces. And today, we are going to piece back together the world that was forced out of existence. Let's start with a mystery. In the late 1700s, astronomers noticed something odd. The planets seemed to follow a rough mathematical pattern known as the Titius-Bode law. Mercury, Venus, Earth, Mars. Then, a gap. A huge empty region where another planet should have been. And beyond that gap sat Jupiter. Many astronomers became convinced that a missing planet was hiding there. So they began searching, year after year, night after night, until January 1st, 1801. An Italian astronomer named Giuseppe Piazzi discovered a tiny object, exactly where the missing planet was supposed to be. At first, everyone celebrated. The lost planet had finally been found. It was named Ceres. But then the excitement collapsed, because Ceres wasn't a planet. It was tiny, only about 940 kilometers across, smaller than many moons. Then astronomers found another object, then another, then another. Suddenly, the missing planet wasn't one world, it was thousands, then hundreds of thousands. Today we know there are millions of objects orbiting in that region. Not a planet, not even close, just fragments, debris, broken pieces. And that created an even bigger mystery. What destroyed the missing planet? Because surely all these rocks must be the remains of something larger, right? Wrong. And solving that mystery would completely change our understanding of how planets are born. For decades, scientists imagined a dramatic story. A giant planet once existed between Mars and Jupiter. Then somehow it exploded. Maybe a collision, maybe an internal catastrophe, maybe something even stranger. It sounds convincing, but then astronomers did the math, and the numbers ruined the story. The entire asteroid belt contains surprisingly little material. Add up every asteroid, every rock, every fragment, every grain of dust, and the total mass is only 4% of Earth's moon. Think about that. Not 4% of Earth, 4% of the moon. If you somehow merged every asteroid together today, you'd barely get a dwarf planet. But mass wasn't the only problem. The asteroids themselves were telling a completely different story. If they were fragments of a single destroyed planet, you'd expect them to look similar. Instead, they're wildly different. Some asteroids are made of nearly pure iron solid. Others are fluffy, carbon-rich dirt balls barely holding themselves together. Some are dark as coal. Others are surprisingly bright. Some appear dry and heavily baked by the sun. Others contain minerals that formed in much colder environments. It's as if someone dumped pieces from entirely different worlds into the same region of space. The evidence refused to fit the theory. The asteroid belt wasn't the shattered remains of one planet. Nothing was destroyed, because nothing ever existed. It was something much stranger, a planet embryo, a world that never finished forming. And now the investigation shifts. Because if a planet was trying to be born there, what stopped it? To understand the answer, we have to travel back 4.6 billion years. The solar system wasn't made of planets. It was a giant disk of gas and dust surrounding the young sun. Tiny grains collided, stuck together, formed pebbles. Pebbles formed rocks. Rocks formed mountain-sized objects, and eventually those objects became planets. At least, that was supposed to happen everywhere, including the region we now call the Asteroid Belt. Planetary embryos were already growing. Then Jupiter showed up. And Jupiter wasn't just another planet. It became a monster, containing more than twice the mass of all other planets combined. Its gravity reached far beyond Jupiter itself. Every time an asteroid orbited the sun, Jupiter gave it a tiny gravitational tug. By itself, insignificant. But over billions of years, that's a different story. Imagine trying to build a house during a constant earthquake. Every time rocks attempted to merge together, Jupiter disturbed their orbits. Instead of gentle collisions that created larger worlds, the impacts became violent. Objects smashed apart, fragments scattered, growth slowed, then stopped. A planet was trying to be born. Jupiter kept punching it in the face. The asteroid belt became a cosmic construction site trapped in permanent demolition mode. But even that isn't the weirdest part, because Jupiter didn't merely stop a planet from being born. It may have completely rearranged the solar system. For a long time, astronomers thought planets formed roughly where we see them today. Then evidence started piling up that didn't make sense. Mars was too small. The asteroid belt contained unexpected mixtures of objects. Some asteroids looked dry and rocky. Others appeared rich in water and carbon compounds. How? Then came a radical idea, the Grand Tack hypothesis. According to this model, Jupiter may not have stayed put. Instead, shortly after forming, Jupiter migrated inward towards the sun, like a wrecking ball moving through the young solar system. As it traveled, its gravity scattered material everywhere. Then Saturn formed. The two giant planets became gravitationally linked, and remarkably, they reversed direction. Jupiter turned around and migrated outward again. This migration would explain multiple mysteries at once. Why Mars ended up undersized, why the asteroid belt lost most of its material, why completely different asteroid types became mixed together. If this model is correct, the asteroid belt isn't a failed planet, it's a fossil, a preserved record of one of the most violent events in solar system history. But there is still one final twist, because these ancient leftovers may have done something extraordinary for Earth, something that affects every living thing watching this video. Today, many asteroids appear dry and lifeless, but not all of them. Some contain water, organic molecules, and carbon-rich compounds among the oldest materials in the solar system. And that creates another mystery. Earth formed in a region that may have been too hot for large amounts of water ice to survive. So where did Earth's water come from? One leading possibility points directly towards asteroids. During the chaotic early solar system, countless impacts bombarded the young Earth. Asteroids crashed into the planet for hundreds of millions of years. Some may have delivered enormous quantities of water. Others may have brought the chemical building blocks needed for life. In other words, the same region that failed to create a planet may have helped create a biosphere. The asteroid belt might not be a monument to failure after all. It may be one of the reasons we're here. What looked like useless debris may actually be evidence of our own origins. At first glance, the asteroid belt seems unimportant, but the deeper we investigate, the stranger it becomes. A missing planet that never existed, a fossil record of planetary migration, and perhaps the delivery route that brought water and life's ingredients to Earth. The asteroid belt isn't the scar left behind by a battle that shaped the entire solar system. And if Jupiter had behaved just a little differently, there might be another planet in our sky today. Or perhaps there would be no Earth at all.